Hello. Hello, is it audible for anyone? Yeah, I'm audible, right? Yeah, 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 thank you. Yeah. Okay. So this is week 4 session, no? You can ask any doubts from week 4 or any week. Anyone of you do you have any doubts or yeah, please ask. If you have doubts, please ask. Okay. How many of you have watched week 4? How many of you have watched week 4? Jai Shri, did you watch week 4 contents? Srinidhi, Ram, Sahitya, Vijay. Have you watched week 4? Do you have any doubts from week 4? Hello.
I haven't started yet, ma'am.
Okay. Others? Others, have you started? Okay, just a simple question to everyone. So, yeah, please speak up. Then only this session will be interactive. So, if you wanted, so in your classroom, you wanted to find the students who have same date of birth. So let us say now Sahitya's date of birth is today 31st March, 31st May. So we wanted to find all the students whose date of birth is 31st May, that kind of thing. If you wanted to do, then how can we do? Like, can you just tell how will you do? Yeah, generally in your classroom, if you wanted to check if any others also having same date of birth like 31st May or any birthday date, if you wanted to check, then how will you check? Yeah, normal things only, no? This is normal. How will you do that? Any one of you please tell. How will you do? Yeah, Srinidhi, Jayashri or Sahitya, Ramu, Anshi. Yeah, please tell. How will you do that? So generally, what will you do? You will just see. Okay, in your classroom, you will go student by student or roll number by roll number and see what is their date of birth. If the date of birth is same, then you will say this student date of birth is also same, and you will store the roll number or roll number of the student. The similarly for other students also, for every other students also, you will compare no the date of birth. The same thing here also. Here also we will do in the first lecture. The same thing is explained. Okay, we will use the nested iteration to find. So if you wanted to find the students who have the same date of birth, what will you do? You will compare each and every student with the other student. How will you do that? By just checking one student date of birth with the all other students. Same happens. Okay. Yeah, who has joined newly? My Magesh, right? Hello.
Good evening.
Yeah, good evening, Magesh.
Ma'am, my name is Rohit, ma'am. This is my father's
Sorry.
account. My name is Rohit, ma'am. This is my father's account.
Okay, okay, Rohit. Could you please tell, have you watched week 4 videos, lecture content?
Not yet, ma'am. Today I'll see it.
Okay, okay, no issue. Okay, from week 3 or any week, do you have any doubts? Any others? Yeah, any doubts you have or not? Anything like if I wanted to explain?
No.
Hmm. So generally, week 4, this the last lecture is like summary of week 1 to 4. Okay, week 4. So what we have begun initially is with iterations, variables, all the things, no, in the first week. So what is an iterator? Any one of you please tell what is an iterator? Anyone of you, could you please tell what is an iterator? Iterator is nothing but the if we wanted to repeat a process repeatedly, if we wanted to repeat something repeatedly, then we will use the iterator. So if we wanted to count the number of cards, then what will you do? You will go by each and every card and you will increment the value of the variable count. So the process which we are doing for each and every card, that is iteration we are doing now. So the iterator is the most commonly used pattern in computational thinking. And what we will do, we will just repeat this process for each and every card, that is iteration, doing the some task repeatedly, and the task is repeated for each and every card. So what does it represents? The procedure of doing some task repeatedly. Iteration represents the some procedure of doing some task repeatedly and requires an initialization step, the steps for the task that needed to be repeated, and the way to determine when to stop the iteration. So how will you check when to start the iteration and when to stop the iteration? So initially we will check whether we have more cards in our pile. If we have more cards in our pile, then only we will go and do the iteration. So there is some condition also to stop the iteration, and some task will be performed repeatedly. Okay, what are variables? Variables are nothing but they are, so if you wanted to store any intermediate values in our iteration, we will use the variables. So variables are nothing but the storage elements, we can say, where we can hold some values in it. Variables are given starting values at the initialization step. At each repeated step, the variable values will be updated. So initially, if we wanted to count the value of count the number of cards in a deck, then what we will say, we will initialize the value of count to 0, and then after each and every iteration, we will increment the value of count. That is what here it is telling. Variables are given starting value as the initialization step, which is count equal to 0, and after each and every step, the value of variable will be updated. Initialization and updates of variables are done through assignment statement. Okay, we are just assigning the values to a variables. These are flowcharts. You have already seen that. And so next thing is data types. We have seen we have basic data types like boolean, int, character, and also string data type. There are more subtypes. Boolean is nothing but true or false. Integer is like all integer numbers, so negative numbers, positive numbers, and zero also included. Character is nothing but a single character. Mm, Alpha, all alphanumerics, and also special characters comes under the character thing. String is nothing but collection of characters. What are subtypes? Subtypes. So we have seen subtypes also like marks. In the marks, these are also type of integer, but does not contain negative values. Are you following? Can I get yes or no at least?
Yes, ma'am.
Okay. Okay, then we have seen what are lists. So basically, integer, everything, whatever the basic data types can hold only single value at a time, right? Integer can hold either 20 or 30, some value, only one value at a time. But if we wanted to store multiple values at a time, then we can go for list or records. So in the list we can store multiple collection, many values at a time. So in a list, all the data items typically have the same data type. Typically, it is not necessary, but typically it has the same data types. Like it can be list of integers, list of strings, or list of boolean, something like that. But we can include other data types also. But mostly we are using the same data type elements in our list. Whereas list record has multiple named fields. So record is something similar to your dictionary. So you will have key and the value, corresponding value. So if you, in the record also you can store the multiple values. Okay, it can be of different data types. The values can be the key can be of string and the value can be of some other types. Let us imagine like phone book. What you will say, there will be some person name, and corresponding to that person name you can store the person phone number. So person name is of type string and the phone number can be of type integer. Okay, so we can store multiple values in list and string, whereas record list and where record is like key value pairs we will store in the record, and list is simply a list. So generally what we have seen next is filtering. What is filtering? Just separating. We can filter our cards based on some particular decision. So if we wanted to just count the number of students from Chennai, then we can apply a condition and in our iteration, and then we can filter. So how to apply condition? We can check if student or if that particular card city is Chennai, then we can filter that card, something like that. We can count the students. So what we can say, if x dot city equal to Chennai, then we can increment the count. So that kind of thing. So filtering, like we can separate the cards based on some condition. Okay, filtering makes a decision at each and every step whether to process an item or not. So for each and every card we will see whether the card is from Chennai or whether the student is female, something like that. Any condition we can check for each and every card, that condition will be checked and the process will be repeated. Okay, in the iteration, this introduces a decision steps within the iteration loop. Expressed in pseudocode, it will look like something this like. So initialize, first in our pseudocode we will have some variables, initialize variables. So imagine the variable can be count. So count equal to 0 we can initialize here, and we can check for some condition while our pile has more cards. Then we can continue the iteration. If the student is from Chennai and female, then we can update some count value. So this is some syntax. Okay, this is the semantics, like this how we will use an iteration and filtering. Prepare the final results first from variable value. So we can get the final value from this variable, whatever variable we have initialized. The same thing, filtering only. We are talking about filtering only. Next, you have seen procedure and parameters. Can anyone tell what is a procedure? Any one of you, please, if you know, please tell what is procedure. What is procedure? Please, someone, please, could you please tell what is procedure? So, okay, if we wanted to compute the sum of mathematics marks of a student, of all students, then the logic will be same. If we wanted to compute sum of physics marks to the students, the logic will be same. If you wanted to compute chemistry marks also, logic will be same. Every time it is not required to write the same same what iteration again and again, same thing again and again. So basically, for some to do some things, like to compute some of the marks, or to filter the students some based on some condition, the steps will be same. So it is not required to write the same thing again and again, right? So sometimes we have to write the piece of code again and again with small differences. So basically, if you wanted to compute mathematics, you will use the subject as mathematics. If you wanted to compute the physics sum, you will use the subject as physics, and everything will be same. So only with some difference, we have to repeat the same code again and again. Instead of that, what we can do is we can use the procedure. A piece of pseudocode can be converted into procedure by separating it out from the rest of the code. So we can just separate whatever the thing, like calculating the sum of physics or sum of chemistry marks, the sum logic we can separate, and we can make it as procedure, so that we can reuse that thing for each and every what subjects. Some variables or constants used in this piece of code can be replaced by a parameter variable. Okay, what we can do is, let us say, okay, finding max of a subject. Here the example is taken as finding the max marks of each subject. How to find the if let me see if there is some code or not here. Okay, code is not there. I will write my own that here. My screen is visible or not? Word document.
No, ma'am.
Okay. So if you wanted to find max marks of a subject, maximum marks of a subject, then how will you do? How will you do generally? So we want a variable to store the max value. So I'm saying max value is 0. Okay. Then we have to iterate through each and every card. So what we will check for some condition, whether while pile 1 has more cards, we will check has more cards. We will check. Okay. If it has more cards, then we will continue the iteration. So how to continue the iteration? How to see? We want to find the max. So what we will do, we will check the current card max value of mathematics marks, let us say. Then what we will say, we will check if x dot mathematics current card mathematics marks is greater than whatever our max value currently has, then we will update the value of variable max. And then we will say max equal to x dot mathematics. Okay, that thing we will do. So the same thing. This is like finding max of mathematics marks, maximum marks of mathematics marks. If you wanted to find the maximum marks of physics marks, then everything will be same. Generally, everything will be the same. Only the thing is, instead of mathematics, we have to change it to physics. So if we wanted to find maximum marks of chemistry, also everything will be same, logic will be same, just we have to replace the subject name with chemistry. So instead of writing this piece of code again and again, the same thing, what we can do is we can write something called procedure. In the procedure, what we will do, the procedure we will give name procedure find max. The name of the procedure is find max. Okay, and then we will write whatever the steps. It can take some parameter. Here we are passing subject. S- we can say x dot subject, some subject, the name to the wait. So parameters we are enclosing in brackets. Oh, sorry. Okay, parameters we are enclosing in brackets, and we can say here some variable a or something, because we have to pass subject no here, because subject is changing each and every time. Physics is one time, mathematics is one time, and chemistry is other time. So just we want one parameter, that is our subject. So find max is the name of the procedure, and a is the parameter which is subject, which is changing each and every time. So we can include that, whatever the rest of everything in our procedure, whatever the logic we have to write, we can include that here. Max. So instead of this, we can say x dot a. A is nothing but our subject. So instead of a, I will give some meaningful name, that is subject here. It is nothing but x dot subject. I will write here. So at the end, what I can say, n find max. This is how we will write the procedure. Here also we have to say max equal to x dot subject. Now how to call this procedure? We can call this procedure by saying, so procedure have to return something, no? It is returning max, return max. Okay. Now how to call the procedure? We can say some variable, a variable max, max equal to sorry, find max of mathematics. So this will give, if we call the procedure by you by giving mathematics, then the subject will become here mathematics, and it will find the, it will return, the procedure will return the maximum marks of maximum mathematics marks. Okay, if we say max equal to find max of physics, then the procedure will give the maximum marks of physics. Similarly for chemistry, has, like, everyone, have you understood why we use procedure and how to write the procedure? What is the purpose of procedure? Yeah, someone please reply whether.
Yes, ma'am.
Okay, the purpose of procedure, and if anything is not clear, any one of you please ask. Okay. Okay, the procedure is, sometimes we have to write the piece of code again and again with small differences. A piece of pseudocode can be converted into procedure by separating it out from the rest of the code. Some variables or constant used in this piece of code can be replaced by parameter variable. Okay, now what is parameter? The subject, whatever we give, that is a parameter. Like here, I'm writing here as subject, no, this is parameter. This value is changing each and every time. Whenever i whenever i call the procedure with mathematics, the value will be mathematics. Whenever I call the procedure with physics, the value will be physics. Okay. some variables or constant used in this piece of code can be replaced by a parameter variable. Instead of writing the code again and again with small differences, we now just have to make a call to the procedure with different parameter value. So instead of writing the same code again and again, we are calling the procedure by giving the different values that will automatically will compute the whatever we require. Okay. Mm. Example is finding maximum marks of a subject. Okay, we have already seen what is the purpose of iteration. Okay, what is the purpose of iteration? Single iteration we have seen. No, simple examples of this are count, sum, average. If we wanted to count the number of cards in a pile, we will do an iteration. We will iterate through each and every card and will increment the value of count every time. Similarly, for sum also, not to find the sum of totals, we will do the same thing. Instead of count, we are just updating the sum value every time. Similarly, for average also, we will use an iteration and we can find the values. So we can do the simple things by using one iteration. We could also do the filtering and everything by using the simple iteration. Okay, we could also collect the list of elements, everything by using the simple iteration. But what is the okay, in the week 4, basically we are doing two iterations. We have seen single iteration. In the week 4, it will be two iterations, iteration in an iteration, which is called nested iteration. Why do we need nested iteration at all? We can do only the simple things by using single iteration. Okay, using the first iteration, but in order to do some complex things, we need two iterations. Okay, that's why we will use the two iterations. But here this iteration is different. Doing two iteration one after other, this is different. Here, first in the first iteration, we will find the sum, and in the second, j- in the next thing, we will just calculate the average. In the first iteration, we are just sorry, give me a minute. In the first iteration, we will do the sum, and in the next thing, we will do some computation. The variables like average, maximum, or something we can do in the second iteration. Let us say if we wanted to find the average, then what we will do? We'll find the sum first, and then in the just give me a second. Okay, just I will be back. Sorry for that. Yeah. Okay. In the first iteration, in order to find average, how will you do? If you wanted to find average marks, average mathematics marks, or something, average max, I will say, how will you do? You will find first, you will find need to find how to find average. Will Average is sum divided by total number of cards. That will give the sum of mathematics divided by the number of cards. Sum of all students mathematics marks, students max marks divided by number of cards, you will get the average of mathematics marks. So in order to find the sum, we need one iteration, and in order to find the number of cards also we need one iteration. So in this iteration, what we can do here, we can just say here we have variable here. Okay, I will just the same thing we will do here. Sum equal to 0, we will say. and no filtering is required. Sum equal to, we can say, sum equal to sum plus x dot mathematics, and we can say count equal to count, also we want count equal to count plus 1. That thing we can do in an iteration. And after finding that, okay, 1 is required, count is also, count also we should initialize. After getting sum and count, after getting the sum and after getting the counts, just we need average equal to sum by count we can do. Sum by count, okay, where is the big slides? Okay, if we wanted to find above average student, if we wanted to find above average students all the, now average, let's say we got average something like 50 value. Okay, if we wanted to find all the students who are who has got above this average, then we need to do another iteration also, while pile 1 has more cards. And we will see, and what we will see, if x dot sum x dot total is greater than x dot mathematics, so we are checking now. Okay, if mathematics marks, if mathematics marks is greater than average, mathematics marks are greater than average, then we can maintain another variable count 1 something, then we can increment count 1 equal to 0, then we can say count 1 equal to count 1 plus 1. So here what we are doing, what I'm telling is, here we are doing two iteration. First iteration we are doing some operation, in the second iteration we are performing another iteration, another operation. So in order to find the number of students who are above the average who are above, who has got above a- above this average mathematics marks, we need to do two iterations. First iteration is to perform sum and count to get sum and count, and then we will compute the average. In the second iteration, where calculating the number of students who has got above mathematics marks, above the average marks of mathematics. So here we need two iterations, one is for doing that operation and other is for counting the number of students. So we can't do this thing in single iteration. Okay, some things we cannot do in single iteration, we need two iteration, one iteration after another iteration. The same thing, same this example we have seen, find the above average students or above average mathematics students we have seen. And other example is like find out the more frequently occurring word, higher higher spending customers. So we can find these things also using two iteration, one after another. So next thing is iteration within an iteration, that is nested. Previously, what this is also two iterations, but here iteration within an iteration, that is nested. If we need to go beyond the relationship between an element and aggregate of all the elements to expressing a relationship between any two elements. If we wanted to express relationship between any two elements, like if we wanted to count the number of students who has got 80, c number of students whose name is same. So then we wanted to compare each and every student's name with the other student. So there we are doing nested iteration, we will need to do one iteration within other iterations. Okay, if we wanted to see, same examples we can give, right? If we wanted to see the words, the who the same, like the words which have the same count or something like that, then same letter count, then what we can do, we have to compare each word letter count with each and every other letter count, then only we will get the number of words that have the same letter count. Okay, so that to perform that kind of operation, we cannot do that kind of operations within single iteration. Okay, I will write the example in word document, then it will be clear. Okay, same thing I will here. If we want to find all words, all pair of words that have same letter count, then how to do, can we do that in single iteration or doing two iterations, one iteration after other, we'll see. So let us say, okay, simple example, he and is, again to if. So all these words have same letter count, this word's count is 2, and let us say she was, okay, this word's letter count is 3. Okay, letter count here 3, and number of pairs is 2, here number of pairs is 3. Okay, we have three words with the same letter count 2, and we have the two words with the same letter count 3. So similarly, we can have where, here the rain, everything. This has letter count 4, and we have words. So if we wanted to find all these pairs of words who has same letter count, so all these things should be counted, then how can we do? Can we do it in single iteration? Do we need, how many iterations we need? Any one of you, how to solve this thing? If you wanted to find all pairs of words with the same letter count, then what we can do is, so what is the answer of this question? Any one of you, like here by looking this example, can you tell, if we wanted to find all pairs of words that have same letter count, here we have seen these pairs of words which have the same letter count, then what is the answer of this question? It is, anyone? Yeah, anyone of you? It is 3, no? Now three pairs, like we have three such pairs which has same letter count. Okay, three such pairs we have same letter count. Okay, and now how to do that? In the first iteration, we want some variable to store the count of words, count of all such pairs. So count equal to 0, we have to initialize. Count equal to 0, we have to initialize, and then we want to iterate while pile 1 has mo- more cards. Okay, we have to iterate over the cards. We want to compare, move the current card, move x to pile 2, we will say, no, move x to pile 2. Instead of pile 2, I will move it to, okay, pile 2, move x to pile 2. Then while pile 1 has, while pile 1 has, so why I'm doing this, I will say, most of you haven't watched lectures, no, so I am explaining. First word is he, let us say. Second word is she, and third word is was, let us say. And next word is. Okay, and the other word is if, let us say. Okay, now we wanted to find the pair of words which have the same letter count. So how to do that? We have to check x letter count is 2, and its she letter count is 3, was letter count is 3, is letter count is 2, and if letter count is 2. So first this is our pile. Let us say this is our pile. Okay. Now what we wanted to do? We want to check each and every card. Now he card I have taken. Its letter count is 2. Now we wanted to get, we have to check whether other cards are also having 2 letter count. Okay. Now is and if are having 2 letter count. How to do that? We will check he card with she and was and is and if. Okay, all with all other cards we have to compare. So how to do that? In the first iteration we will say, in this iteration we will take x is not, our x is nothing but here he is our x. Okay, now I have to compare it with she, was, is and if. So I have to iterate again. So for this only I am writing another loop here. Inside a loop I am writing, inside the while loop itself I am writing other loop, because I have to compare this particular he card. In the particular iteration itself I have to compare this he card with all other cards. So I have to iterate again through all other cards in our pile 1. So I will see whether pile 1 has more cards. Okay, if it has more cards, then what I will say, if, okay, move this card name I am giving as y. Move y to pile 3. This is temporary pile. I will say why this pile is required. If x dot letter count lc, I am saying here letter equal to y dot lc letter count, then I have to increment the value of count. That is like pair. We got a pair whose letter count is same. So we have to count that pair. So I will increment the value of count. Count equal to count count equal to count plus 1. Okay. Okay. Why here? Why I'm moving this pile, this y card to pile 3, I will say. So now, okay, now in the first iteration I have taken he card, and in the nested iteration I have taken she, and then I have compared. After comparing, should I move it, should I discard this card? No, right? I have to compare she card also with all other cards and see whether whether this the she card letter count is same to any other other card letter count also I have to see. So that's why I'm moving the nested iterated cards to different pile called pile 3. After checking all the iterations, after checking all the inner, see, I will compare he with she, he with was, he with he's, and he with if. I will compare with all these things, all other cards, and after comparing all the other cards of this cards we have moved to pile 3. No, after comparing he with all these other cards, then we will say, then we will check this condition also, then we will say move all these cards to pile 1. Move pile 3 to pile 1. We will say move y from pile 3 to pile 1, y to pile 1, pile 1. Move all cards from pile 3 to pile 1, we will say. Move all cards from pile 3 to pile 1. When we are moving cards from pile 3 to pile 1, after completing the inner iteration, after checking all these cards, after comparing he card with all these other cards, finally we are moving all these cards from pile 3 to pile 1, because we have to compare Now pile 1, this pile 1, this he card is moved to pile 2, which is discarded, and then these cards are moved back to pile 1 again. So we can continue the iteration. Now she card also will be compared with all other cards like was, is, and if, and we will check whether those letter counts are same. If they are same, then we will increment the value of count. Okay, is it clear, or do you, is it clear? Any one of you, can you please tell whether it's clear, or should I need to explain again? Hello.
It is clear, ma'am.
Okay, for everyone?
Yes, ma'am.
Okay. Okay, we are not discarding the card. So this is like entire week 4 is this one only, nested iterations. Why do we need nested iteration? We need nested iteration to perform some complex operation, like in order to find the relationship between cards, between, if we wanted to find the pair of something, uh, pair of students who have same date of birth, or pair of students who have same name, or pair of cards, pair of words which have same letter count, or pair of customers who have purchased same items. For all these things we cannot do using a single iteration or iteration after iteration. So for these things we need to perform nested iteration. That means we have to compare the each card value with all the other cards. Okay, as we need to find the pairs after comparing he card with all other cards, she card, was card, or is card, and if card, all these cards are also we have to compare with all other cards. That's why we need nested iteration. Okay, I will go back to this summary slides here. Okay, we will do one iteration within another iteration. Example, find out if two students have same date, birthday and month. Okay, let us do the same example for same birthday and birthday thing. Any one of you please tell me how to do? Yeah, you should help me in coding this, in writing this. Okay, how to do if we wanted to find the pair of students who have same birthdays, same date of birth, same month and same year of birth. Okay, find pair of students. Yeah, yeah, please come.
Ma'am, we can have count Jan equal to 0, count Feb equal to 0, all the way till December, and then
uh,
we count the number of cards from there.
okay, I understood. Okay, if we wanted to find all the pairs of students that have same month of birth, month and year of birth, year of birth. So what thing you are telling is, yeah, this is good. Actually, this is the next concept I wanted to teach. This is, you will say, uh, Jan, for Jan you will initialize one variable to 0, something like that. No, for
Yes,
Feb,
ma'am.
you are initializing it to 0. So yeah, but you have to check every time whether it's from Jan or Feb or something. No, I will write your code. So yeah, just guide me. Like, yeah, just for example, we are taking only the pairs of students. Now you will do the same thing, right?
Yes, ma'am.
The same thing. Pile one has more cards. Pile one. If x dot, I can say if x dot dob, date of birth, equal to y dot date of birth. Simple, no? If y dot date of birth, then I can increment the value of count. We doesn't require all these variables, no? Now, just we have only one variable count, and we are
Ma'am, but
checking.
date
But
of birth will include the date, no, ma'am. Here they are
yeah, it will
asking
include.
only month and year.
Yeah,
We
we can
might not
separate
have.
here. Yeah, in the if condition, we can filter that if x dot month equal to y dot month and x dot year equal to y dot year, something like that. We can write. Okay, month of DOB, something, and something like that we can write here. Only if condition is changing, but everything is same, equal to y dot year. Then it will give us the same answer, no? Here, what
Yes.
answer will we will get? What answer we will get? So let us say if the students, okay, if Jan month and 2000 students are 2, the students will be counted, this pair will be counted. And if Feb 2000, if 3 2001 or 2000, if 3 students are born, and if March 2000, if 4 students are born, then what we will get? If we wanted to what will be our answer, just verbally what will be our answer without coding? If we wanted to find all pairs of students that have same month and year of birth, then how many pairs are we getting? 2 plus 2 pairs of students has same month. 3 pairs of students have Feb month, and 4 students. So totally we will get this many pairs.
Ma'am,
9.
but those 4 students we can have it in 6 pairs, no, ma'am.
Sorry,
Those 4 students we can make 6 pairs. So shouldn't it be 6 plus 2 plus 3? 11.
6. Where is 6? Here we have
March
4 only, na?
2000 there are 4 students, no, ma'am.
Ah.
So 4 students we can make 6 pairs, no, ma'am.
No, March 2000 we have 4. See, let us say the who are those 4 students: Ram, Ravi, Rahul, Ria. Okay, these are 4 students who have same date of birth. Okay, how many pairs can we form?
6.
Okay, just I'm here 4. Just I mean 4 pair. Okay, Ram, Ravi. I will write pairs. Uh, Ram, Rahul, Ram, Ria, and Ravi, Rahul, Ravi, Ria, and then Rahul, Ria. Right? We got all the pairs. Okay. What I meant for here itself, only these 4 pairs. These 4 pairs I am telling. Okay. It's not like 4 students who have same date of birth, 4 pairs of students. Because I'm just okay. I will just show this iteration also here. Count equal to 0 while pile 1 has more card. Move x to pile 2. Okay, now we are starting with Ram. Okay, Ram card we have moved to pile 2 while pile 1 has more cards. Now again, Ram card has already discarded from pile 1. What are the remaining cards? Ravi, Rahul and Riya. Yes, pile 1 has more cards. Move y to pile 3. What is our y? Now we have started with read the top card. No, that is Ravi. In the inner iteration, that is Ravi. Now that is moved to pile 3. If x dot month and x dot year are same, if both the cards are having Ram and Ravi are having same month and year, then I'm incrementing the value of count. Count equal to count plus 1 will happen. Okay. Again, the iteration has, we are in this inner iteration. This iteration has to finish no first. So again, in the inner iteration, the other card is Rahul. So yeah, whether we have more cards in our pile 1, yes, we have more cards in our pile 1. So we have Rahul is a top card. Rahul card we will pick, and we will see whether month and year are same. Yes, we have year is same and month is same, it is March 2000. So count will be incremented. So it will be, count will be 2 this time, right? Count will be 2. 2. Okay. Now, okay, now the RIA card. In the inner iteration, we are seeing RIA card. While pile 1 has more cards, yes, we have RIA. And move Y to pile 3. Okay, Ravi, Rahul are moved to pile 3. Right? Ravi, Rahul are moved to pile 3 and Ram is in pile 2. Okay. We will see whether Ria and Ram month of birth, month and year of birth are same. Yes, they are same. So the count will be incremented. Count will be 3. Okay. Now move all cards from pile 3 to pile 1. So what are the cards now in the pile 3? We have Ravi, Rahul and Riya. These are the cards we have that are moved from pile 3 to pile 1. So first this inner iteration has to finish, then only we will execute this statement. Move all cards from pile 3 to pile 1, then only we will execute the statement after completing this inner iteration. Okay, now Ram has moved to pile 2. Pile 2 we are no more using, only pile 3 cards we are using. From pile 3 all the cards are moved to pile 1. Okay, now while pile 1, this iteration has not finished. Outer iteration, whatever the iteration we have begin earlier, that has not finished. Ram is completed, and from Ram all other cards this iteration we have finished. No, this iteration we have started with outer iteration. For each outer iteration, all these inner iteration has to finish. So for Ram is compared with Rahul, Ravi, Riya. The same thing. Ravi also has to be compared with all the remaining cards. So Ravi, the other card, the top card in pile 1 is Ravi. Now this Ravi card will be moved to pile 2. Ravi will be moved to pile 2. What we are left with Rahul and Riya. We will check whether pile 1 has more cards. Yes, we have Rahul and Riya. Move the top card, that is Rahul card, to pile 3, and we will check Ravi, Rahul's date of birth and month of birth. Yes, that is same. So we will increment the value of count, that will be 4. Okay. Now Rahul has moved to pile 3. Okay, Rahul has moved to pile 3. Now we have only Riya in pile 1. Ravi is moved to pile 2 and Rahul is in pile 3 and Riya is in pile 1. So we'll check whether pile 1 has more cards. Yes, we have Riya. So we'll compare Ravi and Riya's month and year of birth. They are same. So value of count will be incremented. That will happen 5. Okay. Now, uh, what we will see? Whether pile 1 has more cards, we will see. No, pile 1 has no more cards. No more cards. Ravi is in pile 2 and Rahul and Riya are in pile 3. So this inner iteration will stop. This inner iteration will finish, and then this statement will be executed. Move all cards from pile 3 to pile 1. So Rahul and Riya will be moved back to pile 1. So Rahul and Riya we have. So what Rahul card we will pick this time, because this outer iteration is still going on. So previously Ram, Ravi has finished, Rahul is there. So now we are at Rahul. Yes, we are at Rahul, and we will see inner iteration we have to do. No, whether pile 1 has more cards. Yes, we have Riya. Rahul card we have moved to pile 2. We have Riya in pile 1. So we'll check both month and date of year of birth. They are same. So we will increment the value of count, that will be 6. Now Riya is moved to pile 3 and Rahul is in pile 2. So we will say move all cards from pile 3 to pile 1. So Riya will be moved to pile 1. Pile 1. So we will see where now the outer iteration is still going on, because we have more cards in pile 1 in the outer iteration. So yeah, Riya will be moved to pile 2, and in the inner iteration we will see whether pile 1 has more cards. No, we don't have any more cards because Riya is in pile 2 now. So this iteration will finish. So totally we got 6. Okay. So if we get 6 here, if the value of count is 6, the value will be 6 only. Here we no need to do some kind of if we got 4, then if there are four names, then the previously you told me there will be 6, but the value of count we will get the exact value. Okay, count value will give the number of pairs. So the computation is further computation is not required after getting the value of count. Okay. Okay, that thing we have seen for March 2000. The same thing will happen for each and every Jan to February, everything. This each and every card will be compared with each and all other cards. And if their month and year of birth are same, then the value of count will be incremented. This will happen for all cards. So we are not required to worry about the month of Jan or Feb or March, anything. Just we need to compare each card month and year with all other cards, then the value of count will be automatically, it will find as a pair. Okay. Okay, but we have seen how many comparisons, how many iterations we are doing. It is like many iterations, no? If we have more cards, then we need to do many iterations. So let us say if we have n cards, then how many comparisons we have to do? We have to compare with n minus 1 cards. So n minus 1 comparisons we have to do. Okay, for n cards. So what we will do, first card have to be compared with all other cards, n minus 1 cards. So and the second card will be compared with n minus 2 cards, have to be compared with n minus 2 cards. Third card should be compared with n minus 3 cards. It's Are you getting why I'm writing n minus 3? Okay, similarly, if we are at last card, then no need to compare. But if we have two cards, then we have to compare with one other card. So how many comparisons we have to do? It is like sum of natural numbers, no? 1 plus 2 plus 3 plus so on to n minus 1. Sum of n minus 1 natural numbers. It is n into n plus 1 by 2, no? What is our n here? N is nothing but n minus 1. N minus 1 numbers we have here. So it is n minus 1 into n minus 1 into n minus 1 plus 1 by 2, that is n into n minus 1 by 2 we will get. So total number of comparison is like this. So if we have 10 cards, then how many comparisons will this nested iterations will do? 10 into 10 minus 1 by 2, that is 9 by 2. 10 into 9, 9, that is 90. 90 by 2 is 45. 45. This is like too many, no? Too many. So instead of that, there is like concept of binning. Okay, should I continue? Everyone, are you following? Hello?
Yes, ma'am.
Yeah, okay. Did you get what till now whatever I taught? Have you understood?
Yes,
Yes,
ma'am.
ma'am.
Okay. So if we have n cards, then we have to do totally these many comparisons we are doing. This is like too many. The computer is performing many operations. So how to reduce this kind of thing? There is concept called binning for this. So what we will do is like we can bin our card first. So okay, here the students who have same month and year of birth we are checking, no? uh, we can, for this what we can see is we can bin students January's, all the January born students we can collect them in a bin, and all Feb born students we can collect them in a bin. Same, we can bin the students by their month of birth. Okay, and then we can compare. So if we do, if all the January, if there are, okay, two students in January, total we have only 30 cards, no? Two students in the February, we have some 13 students, something like that. Okay, in March, the same thing. If we have five students, okay, here what, here we have 30 cards, no? So 30 into 30, 20, 29 by 2. So 15 into 29. What is 15 into 29? How many comparisons are we getting? Can someone tell? 15 into 29, what is its value? 45. What its value?
435, ma'am.
Only 435. Okay, 435 comparisons we have to do. Okay, we have only two students in January month, so we need to compare each other. Only one, each student with other student. No, only two students we have. So I will compare Ram and Ravi. Let's say, so we'll compare Ram year of birth with Ravi year of birth. So only compare one comparisons we have to do. No, here if we have two students, so here we have to do one comparison. Only one comparison. If we have 13 students, then how many comparisons we have to do? 13 into 12 by 2. 13, 13 into 6. So how many comparisons? It will be less comparisons only. So if we have 5 students, then how many comparisons we have to do? 5 into 4 by 2. 5 2s are 10. 10 comparisons we have to do. So total, so if we just separate the students, and then if we do this operation, then the number of comparisons will be reduced. Here only one comparison we have to do. Here also we'll get some small number only, some small number that will be less than 435, obviously. So the concept of binning is like it will reduce the number of operations that we perform. So first we will so we will bin the students based on a condition, and after binning we will check whether those students have in that particular bin. We will see whether the students year of birth is same thing for other example also. I will just take see the examples from here, from the summary slides. Okay, we could reduce the number of comparison by using binning wherever possible. Okay. Okay, that is binning. Okay, there are no examples here in the lecture, but let us see in the binning thing. Nere- So in the words also, if we wanted to find all the words with the same letter count, instead of comparing all the 30 cards with all the remaining 29 cards, like number of operations we have seen, 435 operations we have to do. Instead of that, what we can see is we can separate nouns, pronouns, and yeah, verbs, something like that. And then within the bin we can see, okay, if we wanted to see the words with the same letter count and same parts of speech, then we can bin the words by the what by this parts of speech, and then within the bin we can do comparisons whether their letter count is same or not. Okay, the question is like, if you wanted to find the pair of words that have same letter count and parts of speech, then we can bin the words by parts of speech, and then we can do the comparison. Instead of comparing each card and every other card without using binning, we can use the in order to reduce the number of operation, we can bin our cards based on some condition, and then we can perform the operation that will reduce the number of comparisons and number of operation we perform. That is the use of binning. Okay, that will reduce the amount of computation we perform drastically. But there is some trade-off also. Okay, the trade-off is like, if the number of bins are more, if the number of bins are more, then the number of comparisons will become uh, more. Okay, the trade-off is there in the lecture, it is there. Yeah, in the summary slide it is not there, but in the lecture it's there. Yeah, at the time you will able to see. Okay, where I will give an example where the binning will not be useful. Okay, if we wanted to find the pairs of students, with same day of birth. Okay, if say with same day of birth, like first, any first, like Jan first or Feb first or any first, let us say something like that, or second or something. If you wanted to find the pair of students with same day of birth, then how we will bin pair of students that have same day of birth. See, what we have to do is like, here how to bin. So we will check whether if x dot day of birth equal to 1, and if then we will bin as one bin, first bin. If the x dot day of birth equal to second, we will bin as second bin. So how many bins we will do? 30 bins we will. So how many if conditions we have to write? There will be many if conditions we have to write, no? So in the previous examples, words with the same parts of speech and letter count, there we will check if x dot parts of speech equal to noun, pronoun. Only we have limited parts of speech, like 6 or 7. But here here we need to form 30 bins, and we have only 30 cards. So that will not be that much useful, that at the time binning. So there is some trade off when to bin, and yeah, when binning will be useful, that also we have to think. And then the number of comparisons also we have to check whether binning will be useful or not. If we bin by day of birth or something like that, we have to do some computation, check ourselves, and we have to decide whether binning is useful or not in our situation, like for our purpose. Okay, we have only 30 cards and there are 30 day of births. If we bin, then we will get 30 bins. How many if conditions we have to write? We have to write 30 if condition. That is not, that is like, that is no logic, no illogical. So yeah, we have to check and we have to do that binning. While performing nested iterations, we have to check whether binning will be useful or not, and then we can go for binning. Okay. Okay, this is mostly the things are nested iteration and binning is covered in week 4. You can see, and I have already given brief idea of procedures and yeah, iterations and everything. No, yeah, any one of if you have doubt, you can ask. Okay, you have one more session on Saturday, right?
Yes,
Hello.
ma'am.
Yeah, please, by the time, please watch the videos. Okay, and then if you have doubt, then it will be much useful. Okay. Yeah, please ask if you have any doubt, you can ask.
We have no doubts, ma'am.
Yeah, thanks. Yeah, Jai Shri, Sahitya, Ravi Shankar.
No doubts, ma'am.
Yeah, thank you, Sahitya. Okay, then we can close the session. Thanks.
Thank
Thank you,
you,
ma'am.
ma'am.
Yeah, bye.